Hey guys, can you hear me?
Yes.
Very good morning and good evening. Just allow us a couple of minutes, guys. We'll get started. We are just waiting for folks to join. People are joining.
Good morning.
Couple more minutes here. So we can get started, guys. Firstly, welcome to the course, and thank you for giving us this opportunity. Let's do a quick introduction before we get started with the actual topic scheduled for today. Okay. So, first things first, how many of you have not joined my demos, and this is your first session or first interaction? Okay, I'll take that as a no from every one of you. Cool.
I joined Suresh.
Okay, so you were not part of the demos earlier, right?
No, I joined your first class, your first demo.
Okay, okay, cool. So first things first, let me introduce myself. I know I have already introduced myself in the demos, but just because, we are starting officially from today, our batch. Okay. So, my name is Suresh, guys. I have, 12 plus years of experience, and all my experience is into data related technologies. I have worked on data engineering most of the time, especially on the distributed computing frameworks. Started my career with Hadoop, and then I got a chance to work on Spark. And from past 6, 7 years, I have been working on cloud. My expertise is into Azure and GCP. I have worked on AWS too, but not as much as I worked on GCP and Azure. So I'm an Azure certified trainer. I have renewed my certification recently. So certification is still active. And talking about training, I have been training folks from past 9 years on various technologies. Again, I started with Hadoop training. Then I moved into cloud, and in addition to data engineering, I also trained folks on Python. Okay, so have trained more than 2,000 plus students, guys, in my training career, and some of them have ended up in really good jobs. So yeah, this is all about me. If you have any questions, concerns, you can reach out to me at any point in time. Okay, not during the sessions. I mean, you can do that during the sessions as well, but if you have any questions and you want to talk to me one-on-one, you can always reach out to me. Not directly, but we have a protocol. You'll have to get in touch with CareerIT folks and they'll be scheduling a call with me. Okay. Now, I have explained all the logistics of the course, how our course is structured, what topics we are going to cover. I hope you must have already received the content from CareerIT folks. I mean, the detailed curriculum from CareerIT folks. And now that it's official, our timings are from 6 to 7. Okay. So I think we are good to start, guys. So I just want you to introduce yourself again. We will follow the same format because I have taken multiple demos, so I couldn't remember, who are part of what demo. Okay, so I request you
First one
to,
is availability of data. Currently, we have
okay. So I would request you to introduce yourself in the chat window in this format. Your name and then current technology you're working on and then your experience. This is an example, guys. I'm Suresh, currently working as a data engineer and I have 12 years of experience. And if you are a fresher, you can just mention your name and then fresher. Okay. So this would give me a fair bit of idea on my participants. Praveen, SQL DBA 10 plus years. Hi, Praveen. Navya, hi Navya, QA 3 plus years. I remember both of you. You joined, my first demo, which was 2 weeks ago, if I'm not wrong. Hi, Sri Lakshmi. Yashwant, hi Yashwant. I remember you too. You are asking about deep dive optimization techniques and then, reading on the query plans and other things, right?
Yes.
Yeah. Hi, Anshu. Hi, Ramakrishna.
Oh, hi, Suresh.
Um, Great.
Hello.
Yeah, Ramakrishna.
Yeah, I have 13 years of experience in IT. Even I have worked in different skills so
Mm,
far. Uh,
to know.
yeah, currently I'm looking for Azure data engineering role.
Got it. Hi, Tejas. This is QL SSIS school coming from Microsoft background.
Yes,
Full stack.
Suresh.
Yeah. Can others also quickly introduce yourself so that we can get started? Okay, no worries. So let's get into the technical topics today. We'll start with our first topic. Hi, Ramtej, Java developer. Great. Coming back from a programming background. Cool. So today I'm going to talk about data, guys, introduction to data. We'll just try to understand what exactly data is, and then different classifications of data we have, and what are the different tools we usually deal with. Okay, so we'll try to understand on these basics first. And tomorrow I'm gonna introduce cloud to you. I'm gonna talk about what cloud is, and then I'll be talking about different types of clouds we have, cloud deployment models, in fact, like public cloud, private cloud, and then hybrid cloud. Then we are hearing a new term called multi-cloud, and then we'll talk about different types of services we have: PaaS, IaaS, SaaS, serverless, right? And on Thursday, I'll be showing you how you can set up your Azure account, and we'll start with our first service, which is storage account. Okay, so I'll be showing you how we can actually deploy storage account, and then I'll be taking around 3 to 4 sessions on storage account, understanding different things. So this is the plan for your first week. Okay, after which we are going to jump into the core of our course, which is Databricks. Okay, so let's get started. So what is data, guys? We'll try to keep this session as interactive as possible. There are few sessions where we can actually interact more than one-way teaching, and there will be sessions where I'll have to teach one way. Okay, but at least whenever we get a chance, we'll try to interact as much as we can. Okay, so what is data? You can use the chat window, or you can unmute yourself whenever you want to talk. Please feel free. Collection of information, okay? So we'll talk about that as well. What is information? Okay. So basically, data is nothing but a collection of raw facts. That is the bookish definition. Data is nothing but collection of raw facts. This is a bookish definition. Okay. So what does it exactly mean? What are these raw facts? Raw facts are nothing but the attributes of the object we are talking about. Now, I'm using some technical jargons here. What is an object? Object is nothing but the entity on which we are trying to collect the attributes. Okay, as simple as that. For example, let me pick a student. Okay, so student will have different attributes, right? Like student name, student ID, using which you can uniquely identify the student, and then student course, and then student location or address, whatever it is. They're all some attributes related to that student. Okay, and then maybe you talk about product data. You have product name, product price, product category, the category to which that product belongs to, and then the product ID, using which you can uniquely identify it. And then if there is any discount, discount on that product, and then discounted price, which is selling price, right? There are multiple attributes that can be stored for a particular product. Okay, and then you talk about sales data. Again, sales data, you have the order ID on which we have, using which we can identify different items we have in that particular order, and then the total order value, the date on which order is placed, and the current status of the order. These are all raw facts about something called as data. As simple as that. Okay. So now information is something which is extracted out of this data, guys. Information is something which is extracted out of this data. So what is that something? Something is nothing but insights. Okay. Say for example, just by looking at the data, you will not be able to interpret anything. But when I say, boss, for this particular quarter, the average sales number per day is, let's say maybe $3,000. That is giving me some good insights. right? Meaning, I pick any day, my daily sale or the sale number would be around in and around that 3,000. There could be some outliers too, but when you take average on most of the days, it's going to be 3,000. Okay, so this is what we call as information. Okay, so data is different, information is different, guys. Okay, now moving on, we'll try to understand different classifications of data we have. Okay, so first one is based on the format. We have structured data, and then we have something called as unstructured data. And then we have something called as semi-structured data. Okay, and based on the relevancy, we have another classification, transactional data. And the second one is historic data. Okay, so let's talk about the first classification and then we'll move to the second classification. Okay, so any idea what exactly, structured, unstructured, semi-structured classification is all about? Or maybe we can start with unstructured data. Any idea?
Unstructured data, it means it's taking of the data is not null value space.
Mhm.
It's a kind of that.
Okay. Any other thoughts?
Unstructured means maybe it's a kind of a raw data, which is not cleaned or unprocessed data or something like that.
Yeah. Images, video files, yes. Okay. So basically, all these answers are relevant, guys. Okay. So talking about unstructured data, right? So generally, unstructured data is something which doesn't have any structure attached to it. Okay. So I might sound like, I'm rephrasing this term unstructured, but that is what it is. Okay. So we'll try to understand what that structure is first. Okay, but before that, let me give you an example. So generally, talking about unstructured data, right, you don't have any structure attached to it, and generally the data is stored mostly in files. Okay, and also your multimedia data is also unstructured, like images, video files, a lot of things. Okay, now to give you an example of this unstructured data, right? Let us imagine you have to store a product detail in unstructured format in a file. Okay, so how the data would look like in a file? Your data would be like a product with ID 1001, name, maybe shoes, uh, pricing, some price, and then some X number, and belongs to the category, some category, and can be sold in locations, location 1, 2, 3, 4, something like this. You'll have a lot of verbose in it. It doesn't have any structure attached to it. Okay, so whatever, see, just very simple, guys. Whatever we talk is an example of unstructured data. Very simple. Might not be stored somewhere, whatever we are talking, but whatever we are talking is completely unstructured data. Okay. Now, what is the problem with this? So, why do we store data? So, generally, we store data to retrieve at some point in time whenever we want to use it. Okay. And the second one, we want to save the data for future reference. Okay. Now, so we're talking about this two operations, right? One is storage and the second one is retrieval. Okay. Now storage, you are storing a lot of verbose in unstructured data. And secondly, retrieval, talking about retrieval. Now just imagine you have some, 1,000 varieties of shoes stored in an unstructured format in a file. Now, if I want to find out, maybe the shoes which are falling into less than 500 price category. Okay, So how can we do that? We literally have to go through each and every line in the file, okay, and shortlist all the shoes which is having price value less than 500. Okay, so basically you are actually doing a text mining here. Okay, so 2000 shoes, okay, I'll still say humanly possible. But what if you have 2 lakh items? What if you have 2 million items? So do you still think the storage and retrieval is as straightforward as having 200 or 2000 items?
No.
Okay, so definitely no, guys. It will become a altogether an AI problem. Okay, so you'll have to, I mean, for you to automate anything, you literally have to implement NLP algorithms. Okay. Now, talking about this structured data, right? To address this, people have come up with something called a structured data approach. Now, they have tried to optimize the storage and you know and optimize the retrieval part as well. And they have come up with a concept called tables. Okay. So whatever data you want to store it in the form of tables by attaching a structure to it. Okay. So how does that happen? Now, looking at the unstructured data and taking the same product example, the first step for you would be to identify the attributes. So attributes could be the product ID, and then a product name, and then a product price. Then you have product image. Okay. And maybe you can have, product, the max discount you can offer on that product. Okay. And the locations that are available for selling this product, so on and so forth. Okay. Maybe I'll remove image here for now. Okay. But, you can actually try to identify the attributes and then store the data in the form of tabular format. How does it work? Okay. So you see ID and the name. Then we have product price. Then we have discount. And, probably you can have another column seller and then locations, something like this. And then you can store products data like this, 1001, 1002, 1003. And then name is, Nike and some Adidas and probably A6, something like this. And then price of this item is 12,000 INR. And then this one is maybe some 5,600. I'm just giving some random number, 3,500. And then maximum discount you can give is 5%. For this one is maybe 20%. And for this one, it could be 0. Okay. And the seller could be, this is X seller, Y seller, and then this is Z seller. Or maybe this can be X seller too. And then locations, maybe this is available currently in Hyderabad and Bangalore stores. Okay. And let's say this is available in Bangalore and Pune stores. And let's say this is available in Delhi and Hyderabad stores. Something like this. Now, if you see, the entire data is organized in the form of a table. Okay, which is having rows and columns. Okay. And this first row, what you are seeing over here, this is what we call as header. Okay, or column names. Okay. So now we have attached a structure to this data, right, in the form of a table. And this structure is what we refer to as schema. Okay, so I'm not talking about, the schema you refer to in a database, but this schema is nothing but the column names and column data type. Column names and then column data type. Okay. So here each column is talking about each attribute, guys. This particular column is talking about ID, which is an attribute. This column is talking about name, which is an attribute. This column is talking about price, which is an attribute, so on and so forth. And now each row is talking about one particular product. Okay. So for example, this particular row is talking about Nike, This particular row is talking about a product from Adidas, and this particular row is talking about product A6, something like this. Okay, so this is a row columnar structure. Okay, now when we talk about schema, we generally talk about the column names and then data type. So here column name is ID, and the data type is a number, which is an integer. Here the column name is name, and the data we are storing here is a string. Likewise, price is a integer, discount is an integer, and then seller is a string, location is also a string. As simple as that. Okay. Now you might ask me, boss, storage wise, I could see the optimization. Instead of storing a lot of verbose, now this looks like pretty organized. Now, what about the retrieval part? So basically, for us to manage this storage structured data, right? People have come up with a tool called RDBMS, Relational Database Management Store. Okay, system, sorry, my bad. So RDBMS, Relational Database Management Systems. Okay, so generally, this provides you with a couple of things. One is the tabular storage, meaning you can actually create tables. Okay, and there is one more thing called SQL. Okay, so it provides us with something called as SQL. SQL is a structured query language. You can actually deal with these tables using SQL, like, creating tables or inserting data into these tables, or maybe you want to retrieve data from the tables. You can do that using SQL, structured query language. Okay. So to deal with structured data, we have a tool called RDBMS, where you are storing data in the form of tabular form. And, we use SQL for data retrieval. Okay, so how easy is using SQL? I'm gonna pick the same example. I want to get all the products which are having price less than 500. Okay, so all I'll have to do is, select star from, let's say this table name is products. Every table will have a name where, price is less than 500. Okay. So you don't really have to be an expert in SQL, guys, but at least looking at the query, you can actually interpret what's happening. Even a layman can understand. So basically, I'm trying to select something from the products table or products where price is less than 500. That's the beauty of SQL. Easy to learn, easy to use. Okay. So you can get all the products which are having price less than 500 just with a simple query like this. That's the beauty of structured data. Okay. Now let's move on to the third category, which is semi-structured. Any idea? What exactly is the semi-structured data?
A table having something with columns and a glob or a blob storage in it.
Not really. That is still structured, I would say, since the blob or whatever you are talking about, the type is still in a table.
Like null values, data is the structured data, but accurate, like attributes, some attributes called null values, comma, space, like semi-structured data is refer for that.
Okay, not complete. But you can definitely infer that the semi-structured data is sitting somewhere between structured and unstructured, right?
Correct.
Okay, so basically this semi-structured data will also have some structure attached to it, but not as clean as a structured data, guys. Okay, there are multiple formats of the semi-structured data. I can pick a few. JSON is an example of semi-structured data, and then CSV, TSV, or whatever it is an example of semi-structured data. XML is an example of semi-structured data. Okay, So what exactly are these file formats? Maybe I'll start with CSV. CSV stands for comma separated values, right? So generally when we talk about CSV, right, this is how a CSV file would look like. I mean, the data in a CSV file would look like. Talking about the same products data, we have ID and then name. And the third one is price. I'm taking only three attributes for now. 1001 and then Nike. And let's say price is some 12K. And then 1002 Adidas. And let's say the price is some 5,000. Okay, and then 1003 A6. Let's say the price is 3,500. Okay, so something like this. You will have data stored in this format in a file. Okay, and that file will usually have .csv extension, which is not mandatory. You can have the same data in .txt files as well. Okay, but the standard is having .csv extension. Okay. So here you still have some structure attached to it. If you observe, it's not, as vulnerable as unstructured data. Okay, or as dirty as unstructured data. Okay, so likewise, if you talk about JSON, so generally JSON will have data stored in a key value format, surrounded by, curly braces. So JSON stands for JavaScript object notation. Okay, and JSON files will have .json extension, and data would be stored in the form of a key value pair, something like this. So first one is ID, and value is 1001, and the second one is name, and the value is Nike. Okay, and the third one is 1003. My bad. Third one is price, and the value is some 12K. Now this is one record. Now you'll have similar objects for other two records as well. Something like this. Now the second record, the value would be 1002. And here it is Adidas. And here the price is 5,000. Okay. And this one, 1003, name is A6. And the price is 3,500. This is an example of the JSON format, JavaScript object notation. If you see, there is some structure attached to it still, but the data is not typically stored in a table. Okay. Now, the third example I'm going to talk about is XML, extensible markup language. And this will have XML, .xml, what you call it? This is called dot, this will have .xml extension. And I'll show you the actual XML file. So this is an XML file which I have created for one of our use cases. Okay. So this is how typical XML file would look like. It will have a root tag which indicates start and end of the file, and then record tag to separate the records. So in XML, everything is dealt in the form of tags, guys, and these are all custom tags, unlike HTML. So HTML, you'll always have the predefined tags. But when it comes to XML, you'll not have predefined tags. They're all custom tags. You can define them the way you want. Okay. So here I have created a record tag to separate the records, and in each record, you will have the data stored in this format. So basically, start tag looks like this and end tag looks like this. So basically, end tag will have a forward slash attached to it. Okay. And the column level information or column level attributes are stored in this way. Name is Suresh, course is PySpark, location is Hyderabad, and then designation is senior consultant. Likewise, for second record, name is Sirisha, course is PySpark, location is Bangalore, designation is consultant, and ends the record. So in this file, we have total 2 records. Okay. And all the structure is attached in the form of tags. This is another example for a semi-structured data, guys. Let me take a pause. Are we good so far with all the classifications?
Can you repeat this point, Suresh?
Okay. So basically in XML, you will have a root tag, which would indicate the start of the file and then end of the file. So for example, if you don't have this particular tag over here, okay, so you'll not be able to understand what is the end of this file. Okay, so here I have given this name root. If not, you can give Praveen as well. It doesn't really matter. So what are the APIs you are using to read this file, right? There you will be specifying that root tag is Praveen. That's the beauty of a custom tag. Okay. And then here in this XML, I'm gonna store data in the form of records. Okay. So to separate those records, I have given a record tag. Again, whenever you are using PySpark APIs or any Python APIs to read data from this particular file, you can specify my record tag is record. Okay, if not, you can give unshoe. Okay, so that doesn't really matter. And inside this record tag, the attributes are stored in this value, in this format. So you have a name tag under which you store the value. Okay, so this is the starting of the tag and this is the ending of the tag. Okay, and this is the value. Okay, just like in JSON, you have given key value pairs, right? Here, the same key is given in the form of start tag and end tag, and then value in between those start and end tags. Okay, so name, Suresh, course, PySpark, location, Hyderabad, designation, senior consultant, likewise for Sirisha. Does that make sense now, Praveen?
Yes, got it.
Are we good, everyone? Can you please acknowledge? You can use the chat window.
Yes, Suresh.
Okay. Now moving on to the next classification, it is based on the relevancy, which is transactional and historic. Okay. So any idea? Transactional.
Transactional is delta, like current data. Historical is hello.
Yeah. That's correct.
Transactional is delta, and historical is like history data.
Okay.
Warehouse data.
Like you can call OLAP and OLTP.
Yes. So transaction data is the current data, guys. You might ask me, boss, what is this current data? I can give you a lot of examples. So any unfinished business, we refer that to a transactional data. Meaning, let's say you have placed an order. Until and unless the order is delivered and the return period is over, till I have my liability to that particular order, it is transactional. And once my liability as a business is over, that will go to the historic data. That will no longer be a transaction data. Okay. So can we afford to lose that data? Definitely no, because we'll be using that data for our analytics. Okay. Maybe to run your ML algorithms or AI algorithms, or, people are talking about fancy words, right? Different fancy words, agentic AI, whatever it is, right? For all those things, we need data. Okay, so we cannot afford to lose the data. So generally, what we do is once the relevancy is over, then we move that data to a different source altogether, and we'll still have it. Okay, for our analytics purpose. I'll talk about what those tools are shortly, but yeah, transaction data is current data. Okay. Another example for transaction data is your login data. Okay, so you are trying to log in to a particular system, providing your credentials. That data has to be transactional, guys. As simple as that. Transaction data should be retrieved just like that. Okay, so you cannot, wait for minutes. Just imagine, I have never faced this situation, but I often hear this from my seniors. When I say seniors, I have 12 years of experience. I'm talking about seniors who are having 20, 25 years of experience, basically are directors. Okay. So they tell me, when they were kids and they have to send a mail or open a Gmail, they just type gmail.com and, they can happily go out, have tea or coffee, come back, and by then Gmail used to open or Gmail used to log in. That's how it used to be, but that's not the case now. Transaction data has to work just like that. Another example, you have logged into Amazon website, and then maybe you want to check for products. In search bar, you will be giving some keywords. Okay, another example of transaction data. What are the data that is getting retrieved in the backend, right? Example of transaction data. Okay, and anything that can be modified, like your addresses, like your card informations, payment informations, they're all transaction data, guys. Okay, and historic data, like I was mentioning, once the transaction is completed, it's a historic data. It will not be edited, or it will not be modified. So generally, to deal with this transaction data, we have OLTP engines. The full form of OLTP is online transaction processing engines. Online transaction processing. Typically, a RDBMS software. Okay. And talking about historic, we call it as OLAP engine. We have OLAP engines to deal with this. So here the full form is online analytical processing. The name itself is indicating, right? And generally we use, data warehouses for this one. Okay, so generally we use data warehouses for this one. Moving data from various RDBMS sources and, modeling it in data warehouse is the ETL process. Okay, so I'm talking about traditional ETL. I'm not getting into the modern data engineering thing, but the traditional ETL sources need not be only RDBMS, but you will have majority of your data in RDBMS, but you can have data coming in from some REST APIs or from some files or any other source. So what you do is you try to extract data from all those sources and, then transform it and then load it to your data warehouse for analytical purpose. When I say analytical purpose, it could be, creating business intelligence reports, or it could be doing, it could be running machine learning algorithms, could be anything. Okay, so that process is what we call as ETL, and we have tools like Ab initio, Informatica, Talend, which would help you to deal with all those things. Okay, and OLTP, RDBMS softwares, the most widely used open source Postgres or MySQL. We have Oracle DBMS, we have IBM's DB2, Microsoft SQL Server, right? We have different softwares, and then for data warehouses, we have Teradata, we have exact target oracles. Okay, so these are all the different tools which we use to build our legacy applications. Okay, the traditional term ETL, originated from this process. Okay, and using our data services, whatever we have in Azure, we will be dealing with all these types of data. Okay, structured, unstructured, semi-structured, doesn't really matter. We should be in a position to deal with them. And then transactional, historic, we should be able to deal with them. And why is this categorization, transactional and historic? Since the data is used for different purposes, the way we maintain and manage the data would be completely different. At the end of the day, it doesn't matter RDBMS or data warehouse, we will still store the data in the form of tables, and we will still use SQL to retrieve the data. Okay, but the way they are stored, meaning the data modeling, is completely different. So for example, you go to RDBMS and transactional data, we use normal forms. Okay, and then you go to OLAP engine data warehouses, we use dimensional modeling. It could be a star schema, it could be a snowflake schema. Okay, so which changes the way you actually store the data. Okay, so that complements your stakeholders, the purpose of your stakeholders. Okay, whoever is using your data. Okay, let me take a pause. Are we good so far?
Yes.
Everyone?
Yes, Suresh.
Okay. So in our course, we will be learning all these things, guys. I might not be dealing with data modeling into OLTP and OLEP, but we will be talking about the best practices of data modeling for columnar file format, distributed columnar file format. Okay. But this is the basic idea, guys, which everybody needs to know. And wherever is needed, I will be deep diving. Okay. So we'll stop here for today. And when we meet tomorrow, I'll be introducing cloud to you, another interesting session. Okay. So that's all from my side. Have a great day and a good night for the folks joining from US. Thank you all and hope you all enjoyed the session, your first session.
Yes, sir.